Alright people, welcome back. So in today's episode we are dealing with problem 139, word break. So let's see what this problem is about. We're still continuing with our series on dynamic programming, and this problem is in the section on strings. So given a string S and a dictionary of strings word dict, we want to return true if S can be segmented into a space-separated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in the segmentation. Okay, so for example, LeetCode, so the output is true, okay. Apple, pen, apple, pen, so the output is true. Cats and dog, so the answer will be no, I suppose, because if you consider these four letters as cats, then you can say and, but then you're left with OG. Maybe you can do cat, send, but then there is no OG word, so that doesn't work. So the output is false. The length of the string is 300. The length of the dictionary is 1000 maximum for both cases. And the length of a word in a dictionary is at most 20. Okay, all the strings of word dict are unique, and that's necessarily true because word dict is a list of strings. Is not a dictionary. Okay, but the strings are like unique. So of course the first thing to do is to simply start at the beginning and then try to look if we can arrive to the end, finding all the words in the dictionary. So the first thing that comes to my mind is simply saying, okay, is this a word? L, no. Is this a word? No. Is this a word? No. Is this a word? Yes. So we know that, for example, we can break the string here, okay? And now we can continue. Is this a word? No. Is this a word? No. Is this a word? No. Is this a word? Yes. And that's the end. So we know that if we start like here, there is a word. Then if we start here, there is a word. And since we reached the end, it is possible to segment this string into a separated sequence of dictionary words. Now here, that's not possible, of course, because this is a word, okay. This is a word, okay. This and are actually in the string, but then there is no word that starts at D and then continues OG. There is no word like that. So the idea would be to create, let's say, so I have my string S, and what I can create is basically a string, like a list of zeros times the length of S. So I define first the length of the string, and then I define a list of numbers that has the same length as S. And in each element of this string, I basically say if it is possible to create a word that starts at that index. So for example, is that possible to create a word that starts at index 0? Yes, I can create cat or cats. Maybe actually thinking about it, we should do the opposite way. So the index associated to the P is not representative of the fact that there is a word behind it, but there is a word that starts at it. No, I mean the opposite. Okay, that's what I wanted to say. If let's say at index I, index I is equal to 1, so let's say that this is index I, that's because this is a word, okay? Or this is a subsequence of words. So I want to make the indexes of the TP equal to 1 if there is a sequence of words in dictionary before index I, okay? So that if I know that here, for example, I is equal to 1, I want to see, for example, if there is another I for which there is a word in the middle between the two indices. Okay, so how can we do that? So of course, for each index, I need to like do a for loop for all the other indexes. So I can do something like for I in range n. Then given an index, I do like for j in range yn. Maybe at this point I can do n minus 1. I'm not sure. But it doesn't really matter because actually before doing this for loop, I want to initialize dp0 as 1. And then I want to do I want to check if I is equal to 1. And then if it is the case, then I do my for loop. Okay, because otherwise, if it is not possible to have a word that ends at that index, there is no point in trying to understand if there is a word that goes from that index to another. So, for example, we know at this point that it is possible. So follow my explanation. We are here, we are at index 0. Is it possible to create a word with length 1? No. 2? No. 3? No. 4? Yes. So for j in range 1n, I want to see, I want to check if s, and then I want to start at I, at end at j. I want to know if this is in word dict. If it is the case, then dpi becomes equal to 1. Sorry, no. dpj becomes equal to 1. And then we continue on, and then we basically, like if dpj, if dpn minus 1 is equal to 1, we return true. If dp0, sorry, if else, return false. There is an error for sure. Yeah, sure, absolutely. You need a double equal sign. Case 3 is false, and we return false for every case. Do we? Yes. Okay, so let's see what's not correct. Let's read the string. Let's take the string LeetCode. Okay. All right. So the length of LeetCode is 8. We create the DP. We create the first value of DP is 1. So for I in range n minus 1, if I is equal to 1, so dp0 is equal to 1. So no, okay, that's the first incorrect thing. I want to check if dpi is equal to 1. Let's run it again to see if now is correct. No, we still return false everywhere. Okay, so if dpi is equal to 1, for j in range 1, okay, no, I don't want to start at 1, I want to start at I. If sij in word dict, dp j, okay, let me run again because we corrected an error. No, we still return false everywhere. Why is that incorrect? That's not good. Maybe, but this is already n minus 1. Maybe I should do j plus 1. Even this is incorrect now because the output is true. Okay, I believe the problem is with the indexes. What we can do here is to basically add 1 here, so that we can start before the word, that we can end before the word. So maybe then I want to do for I in range n, and I want to do for j in range I n plus 1, something like that. Let me see if this solves the problem. Not yet. Okay, let's use the example of LeetCode. Okay, so my DP is now of length 9. I initialize my first index at 1, which is correct. Now, if dp1 is equal to 1, which is the case, I do a for loop for j in range I n plus 1. So in this case, I is 0. If sij plus 1, this is nonsense, I think, ij in word dict. So s that starts at 0 and gets to 4 in word dict. I want dpj equal to 1. Now, j is equal to 4 because this is 0, 1, 2, 3. So I want to play this index to 0. So this is 0, 1, 2, 3, and 4. Yes, it should be there. dpj must be equal to 1. Okay, then I continue for like we are there, and then for I in range n, and so until we are at dp4 equal to 1. For j in range 4 n plus 1, sij, so s4 includes c, o, d, e, so it will be 4, 5, 6, 7, 8. So it's 8. And dpj will be equal to 1, dp8. N is equal to 7. It should be that. It should be correct. It should be correct, guys. And yes, it is correct. Okay. There was a problem with the indexes and yeah, something like that. Wow, guys. Wow. It works. It works. Very good. Very good. All test cases passed. So this is the solution. Let me show you. So the idea is that first we calculate the length of the string, then we define a dp, and then we set the dp is equal to 1 if there is, like given an index, if there is like the possibility to get from like index 0 to index j with a correct and like a sequence of words which are concatenated. And then of course, if the last index of the string of the dp is equal to 1, then it is possible to arrive at the end of the string with a valid substring. So this means that it is like we must return true, otherwise we return false. Okay, I'm trying to understand if it is possible to optimize that. And okay, the point is this takes on, this takes on, and this, well, the point is this can be also an operation of cost on. So actually, considering that we're searching in word dict, like if word dict is length is long m, this is already n times m, which is completely like it's very like complexity consuming. So maybe what we can do here is to say word dict is equal to set word dict, and this means that this operation costs O1. Let's see if this works anyway. Okay, that's fantastic. It's fantastic. That's very good. And we also moved from here, from something like here to here, which means we beat 74%. Now, to be honest, some people told me that we shouldn't look at these like runtime totals, because if I run it again, so now we beat 74%. If I now run it again, I now beat 31%, because it depends on the resource, like the resources that LeetCode has. So there is basically no guarantee that we're doing better than before, but theoretically there is this guarantee. So LeetCode, please solve this problem, because otherwise we will not be able to trust you. So maybe this is the most optimized solution. So this is on, this is on, this is also on. So is that on cube? Yes, it is. It is on square, on cube, and memory-wise it is on and plus m, even though of course this is already from the input. So let's say on, or at most on plus m, which is not fantastic, but it is something. So I believe at this point we can stop here. So thank you very much, people, for watching this video, and see you in the next episode.